Now, guys, let's continue with our next topic, which is we're going to talk about the matter and we're going to talk about the atoms. So, atoms and matter. So, guys, this is where we're going to actually first going to be leaving the math review and actually start talking about some chemistry stuff. Okay, so here, guys, you first of all, let's break down this word atom. What does that word atom mean? Okay, so guys, the word atom, it means where. First of all, where does this word come from? So guys, you see, it's made up of two words, so a and then the tom. So guys, the word. So if I break this into two half, then a means not. Okay, and then tom means to dissect. So to cut or to dissect. Now, where have you seen this tom base word before? So if you think of anatomy, guys, so the word anatomy, which means to study the body by cutting it open. Okay, so not you, in anatomy, you do not study the body from outside. You study it from opening it and seeing inside. So guys, ana means in, and tom means to cut or dissect. So when you cut something and see inside, that's anatomy. So that's what anatomy means. But atom means something that, so tom here again means cut and a means not. So something that is not divisible, something that you cannot cut. So atom actually is just a Greek word for indivisible. Okay. Now, guys, is this still true? Do we still think that the atom is actually indivisible? Now, based on the studies that we know now, we do know that atom inside has subatomic particles, okay? So atom is actually made up of three different particles. So atom is made up of protons and neutrons and then electrons, okay? Now, as the name suggests, guys, for neutrons, they're neutral. They do not have any charge. Neutral, no charge. And protons are positively charged and electrons are negatively charged. You can remember protons start with P and positive starts with P, so you can remember it like that. Now, what we're trying to say is the atom is actually not indivisible. It is divisible. There's actually smaller stuff inside. So these three things that we just talked about, guys, they're called the subatomic particles because they're inside the atom, subatomic particles. Okay, now if you're trying to draw a simple example, guys, a simple model of what atom looks like, and we're going to later discuss, guys, why this model is not even true. What we know now is better models for the atom. So guys, the Bohr's model of the atom, uh, what does that say? So Bohr's model of atom. So this is the simple model that you must have also seen before, where in the atom we say the center is nucleus. This is where we have the protons and neutrons. And then we have these orbits outside where you have the electrons going around. So electrons can be sitting here. Now, this is just like our solar system where you have the sun in the center and then you have the different planets and different orbits. So this is what a simple the simple model for atom looks like. Now, today, guys, we know that this is not the correct model. We'll learn this in more detail later on. Um, but what we see is actually the center is good. The protons and neutrons, yes, we have them in the center. But guys, when we say that for electrons, there's a fixed path where we can always find the electrons, that is not the case anymore. What we now know, the actual better model of the atom, what does that say? That says that we can just predict the probability of finding the electron. So guys, what I'm drawing right now, I'm not trying to draw electrons. So each dot here does not represent electron. It represents the probability or the chances of finding electrons. So when I draw this much more dense, when I'm closer to the nucleus, what is that trying to say? Versus when I draw fewer dots outside. So when you see the outer cloud, what is that trying to say versus the inner denser cloud? What is the difference? The cloud here means what? This cloud here means the probability of finding electron. When I show more dots, when this is more dense, we're trying to say that if you're gonna go and look for electron in this area, it's going to be easier for you to find the electron. There's going to be more chances for you to find the electron here versus you finding the electron in the outer region. So the closer you get to the center of the atom, more chances to find the electron. So we cannot actually predict the actual spot where you can find the electron. So that's why this model is not good anymore. This is the more accepted model these days. So this is your quantum model. Okay. All right, guys. So now when we learn that you have protons, neutrons, and electrons in the atom, we gotta learn the periodic table as well. So we gotta see the periodic table. So this is what your periodic table looks like, guys. And on the periodic table, what you have is different groups and different periods. So if you try to look at the periodic table, guys, you see this number 1, and it goes from 1, 2, 3, and keeps going to 18. So we have total 18 groups on the periodic table. So these vertical lines that you see on the periodic table, those are called groups, okay? And then when you go from left to the right, so these horizontal lines, you see 7 of them, and these are called periods. So you have 7 periods, okay? Periods are also called rows. So if I ask you, how many rows do we have on the periodic table? You're gonna tell me we have 7 rows. And if I ask you how many groups do we have, then the term we can also use is column. So how many columns do we have on the periodic table? We have 18 of them. How many rows do we have? We have 7 rows, okay? Now, let's look at all the atoms here. So we begin with hydrogen, the first atom. And then after hydrogen, guys, we go to the right, and this is helium. This is the second atom. Then we go to the third one. This is lithium. Then we have beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, and so on. Okay. Now, on the periodic table, what you see is, first of all, let's quickly talk about the labeling that you see here, the colored labeling. So all the green ones here that you see, everyone on the left-hand side of the staircase. I hope you guys can see the staircase on the periodic table. To the left of the periodic table, everything is a metal. And to the right of the periodic table, everything this colored in blue, this is non-metal. So you got non-metals on the right-hand side of the staircase, and you got the metals on the left-hand side of the staircase. And things that are sitting on the staircase, as you see here, they're called metalloids. So they behave somewhat like metals and somewhat like non-metals. So they behave like some of these their properties are like metals, some of their properties are like non-metals. Now, that being said here, guys, now let's look at these numbers that we see next to all the atoms. So on hydrogen, do you see these two numbers? You see 1 here, and then you see this 1.008. And then you go to the right, you see helium, and then you see 2, and you see 4. Now let's look at that helium example. Let's write that down here. So helium, it says 2 on the top, and then it says 4.008. I believe that's what it said, 4.003. So 4.003 for helium. These are two numbers that you see on helium on the periodic table. Now, first of all, there are a couple of ways to write these. You can also see how you write the symbol for the atom, guys. So helium is a full name. He is the symbol for helium atom. What you do here is, usually it's actually more common to put the smaller number in the bottom and the bigger number on the top. Okay, now for our purpose for this chapter, when you go to later chapters, guys, when you talk about moles and mass, we'll come back to this. That's where we'll have to keep this full number. We'll have to keep all the decimal places. For right now, to keep our life more simple, I'm going to keep it 2 for the bottom, and I'm going to just keep it 4 for the top. So you round it off to the closest whole number. So for helium, my symbol says 2 and 4. If I go to carbon, it says 6 and 12. Because if you go to carbon and check that, carbon says 6 and 12.01. We're going to round that off to 12. Okay. So guys, we got the symbol for the atom, we got these numbers on the bottom and top. What are they suggesting us? So guys, this number in the bottom that you see, this number is called atomic number. The number you see on the top, guys, is called the atomic mass. So the bottom number was atomic number. This number on the top is atomic mass. It's also very commonly known as mass number. So guys, you see number word and number word here, don't get confused by that. This is atomic number, and this number has the word mass in front of that. So that is talking about the atomic mass. So now, when you see numbers where you see 2 in the bottom and 4 on the top, and then here the periodic table was saying it a little differently, where it had 2 on the top and 4 on the bottom, is never worried about where they're written. The smaller number is the atomic number, and the bigger number is the atomic mass. Okay, so that's what you should remember. So now, let's try to understand what is atomic number and why is atomic mass more than the atomic number. So guys, so for helium, if I ask you, the atomic number we know is 2. So what does that indicate? Because atomic number indicates the number of protons that the atom has. That is the most important number, guys, actually, that belongs to the atom. All the atoms, guys, actually are identified because of their protons, not their neutrons or electrons. So if I ask you, helium has how many protons and neutrons and electrons, then you're going to be using these numbers to answer this question. So guys, helium has how many protons? It is a number, its atomic number is how many protons it has. So for helium, that number is 2. So 2 protons. So if I ask you for carbon, what is that number? For carbon, that number is 6. So it has 6 protons. Okay. Now, when we see neutrons, what is neutrons? So guys, neutrons is basically, let me give you guys the formula for atomic mass. So guys, atomic mass, as you noticed, was bigger than the atomic number. It is because atomic mass is actually equal to number of protons plus the number of neutrons. Okay, so guys, if your mass, if you have, let's say, 2 protons and 2 neutrons, then your mass number is going to be 4. It's as simple as that. Okay, now let's try to answer what we have here in the question. So the question was that how many neutrons do we have in helium? So helium has 4 as the atomic mass. Atomic mass is 4 for helium, and it has 2 protons. So that remainder 2 is coming from the number of neutrons. So it has 2 neutrons because 2 plus 2 will be equal to 4, which is the actual atomic mass. So when you're trying to find the number of neutrons, it is equal to your atomic mass minus the number of protons. Okay, now let's come to the electrons. How many electrons do we have in helium? So guys, number of electrons is equal to the number of protons if you have a neutral atom. What do you mean by neutral atom? You see guys, there's actually no charge on this helium. You're actually going to see later on, we're going to talk about some ions where the atom actually has a charge on it, and then we call them ions. That is not the case here. You're going to see like a positive charge or a negative charge here on the top, which you don't hear, which you do not see here. So here we can assume that number of electrons will be equal to number of protons. So that's also 2 in this case. Now, let's try to answer for carbon. For carbon, you're going to see something very similar. How many neutrons does it have? It is the atomic mass, which is 12, minus protons, which is 6. So 12 minus 6 is 6. Now, electrons for carbon is going to be equal to how many protons it has, which is also 6. Why are these same? Because the atom is neutral. Okay, because they are same, that's the reason why the atom is neutral. Okay, all right. Now, guys, let's talk. Let's take some other example. Let's pick this sodium, which is 11 and 22.99. So sodium, it says 11 and it says 22.99. So if I ask you guys, what is the atomic number, what is the atomic mass? The number on the top here, the smaller number, is the atomic number. Again, guys, please remember, it is not the location on how you decide which is atomic number and which one is atomic mass. Just see which one is a bigger number and smaller number. Smaller number is atomic number. The bigger number is the atomic mass. Okay, so for sodium, if you try to answer the same question, how many protons it has, how many neutrons it has, and how many electrons it has, sodium Na has 11 protons. How many neutrons does it have? What do we do for that, guys? You see, first of all, when you see number 22.99, you must round this off to 23. So instead of using this number 22.99, we're going to use 23 only for this chapter, guys. Later on, we'll actually be using these full numbers, like with the decimal places. But for right now, when you're counting protons, neutrons, electrons, we take whole numbers. So now, guys, for finding neutrons, it is going to be equal to the mass number minus atomic number. So your mass number is 23 minus 11, which is number of protons. This is going to be equal to 12. So that is your answer. That's the number of neutrons you got. How many electrons does sodium have? Is sodium neutral? Yes, I don't see any charge here. So it's going to be equal to number of protons. That's 11. So that's what you got here. Okay. Now, guys, let's go one step ahead and talk about different versions of carbon or other atoms that are possible in nature. Now, guys, carbon can be found in different forms. Like you can find a carbon which is going to say 6 in the bottom and 12 on the top, like the example we just saw. But then there's also carbons where this number on the top changes. So what do you think, guys, is going on here? The number in the bottom is never going to change, guys. If you change this bottom number from 6 to 7, it is not going to be carbon anymore. It will become nitrogen because nitrogen is 7. You can see that, 7, atomic number. Guys, the atomic number is what identifies the atom, so never change that. So if carbon, here we have 3 carbons, 6, 6, and 6, but it's 12, 13, 14 on the top. What does that indicate, guys? The mass number is different. Why is mass number different? See, the number of protons are same, so what do you think, guys, has changed? The neutrons have changed. This carbon right here has 6 neutrons. How do we know that? 12 minus 6 is 6. This carbon here has how many neutrons? It has 13 minus 6, which is equal to 7. So if I'm trying to count the number of protons for each of these, it's 6, 6, and 6, which is atomic number. The next is, what is the number of neutrons? So neutrons are going to be equal to 12 minus 6 in this case, which is equal to 6. In this case, it's 13 minus 6, which is equal to 7. And then the last one, it's 14 minus 6, which is equal to 8. So we got 3 different versions of carbon, which have different number of protons. And guys, this is possible. What are these called, guys? There's a fancy word for these, and this is isotope. So guys, these 3 carbons are isotopes of each other. So I'm not saying these last 2 are isotopes. All 3 are isotopes of each other. The first one is the isotope of the other 2. This last one is the isotope of the first 2. The center one is the isotope of the left and the right one. So all these carbons are isotopes. These are different versions of carbon, basically. And this is possible for many other atoms where there are more than one version for these atoms. And if you try to find out the electrons, guys, the electron is going to be same for all of them because they're all neutral carbon, because you see there's no number here on the top right hand corner. That means there's no charge on this atom. Now, let's take our next example, guys, where we can actually start talking about ions. Okay. So what we were talking about so far was atoms. So this carbon is carbon atom. All the examples we saw, sodium was an atom, helium is an atom, carbon is an atom. But when we have a charge on the atom, we start calling them ions. Okay. They can be positive or negative. They can be positive or they can be negative. The positive ones are called cations and the negative ones are called anions. Okay. So here if I give you an example here of sodium, this is the atom of the sodium. If I change this to sodium plus, what does that mean? Okay, so sodium, guys, we know, let's try to count the protons, neutrons, electrons again. For sodium, we know we have, so the symbol was 11 and then 23 on the top. So we have 11 protons. Neutrons, we got 23 minus 11, which is 12. And electrons, we got 11 because this atom is neutral. There's no charge here on the top right-hand corner. So protons is equal to number of electrons. Now, and just to clarify here, guys, protons and electrons are the ones who have a charge. Protons are positively charged and electrons are negatively charged. So they are the one who are responsible for giving you the charge. Neutrons are neutral, so they don't affect the charge, okay? So in ions, when you make positive or negative, it's the electrons that we change because protons we can never change. Neutrons do not affect the charge. So only thing left is electrons. So it's electron who is responsible for giving us the charged ions. So protons are going to be how many, guys? See, this is still 11 and 23, but it's just a sodium with a positive charge. That is what is different between the first and the second sodium here. So protons are still the same. It is 11. Neutrons is also 12 because it's 23 minus 11. What happened to electrons, guys, here? You see, this sodium has a positive charge. When sodium has a positive charge, what does that mean? It means it has the subatomic particle extra, which is positive in charge. See, if you have 11 protons and you have 11 electrons, they cancel out each other and you do not see any charge here. That's why it's 0 and you don't say that number is 0. But if my number of protons are more than the number of electrons I have, then I'll get a more positive charge. So think about this in this sense, guys. If you lose something negative, you become more positive. For example, if you lose negativity in your life, if you get rid of negativity in your life, you will become a more positive person, guys. The same thing is happening here. If the atom is going to lose the electron, which is negative charge, it will become more positive. So when you see a positive charge here, and you're trying to find the number of electrons, you actually need to subtract the electrons, okay? So how many electrons do we have here, guys? We have 10 electrons. And why did we stop at 10? Why not 9 or 8? Because this plus 1. When we just say plus, we mean plus 1. If it's plus 2, it will say plus 2. If it just says plus, that means it's plus 1. So a positive 1 is indicating that this sodium has extra proton than a neutron, than an electron, sorry. So let me repeat that. When we see a positive charge, a positive 1, that means a sodium has extra positive proton versus the electron. So that's why you need to subtract, guys, the electrons. So if something is positive, do the opposite. Subtract that to get the electrons. Okay. Now, let's take another example. Now, sodium plus 2 does not usually exist in nature very easily, but what we're going to do is just for the fun of, just for the sake of doing it, we'll just do it for the calculations, okay? So it's still got 11 protons and 12 neutrons. That does not change. How many electrons does this thing have? So sodium is supposed to have 11. You see, sodium is supposed to have 11 electrons, but sodium plus 2 has a positive 2 charge. That means it must have lost 2 negative electrons. Okay, yes, you can never change number of protons. So don't think if this thing is positive, it has gained protons. That does not happen because you cannot gain or lose the protons and still be the same atom. Okay, so for you to stay the same atom, your protons stay the same. It's the electrons that you can change. So here, since you're supposed to have 11 electrons and 11 protons to get a 0 charge, here since you have plus 2 charge, that is indicating that this guy must have lost 2 electrons. So now your electrons will be 11 minus 2, which is equal to 9. Okay, and that is what is resulting in the positive 2 charge. So now similarly, guys, if we take an example for the something negative. So let's take an example of oxygen -2, okay? So oxygen -2, first of all, the oxygen is going to be 8 in the bottom It's going to be 16 on the top, so we can find that from the periodic table. Oxygen is 8 and 16. So it has 8 protons, and how many neutrons, guys? It is 16 minus 8, which is equal to 8. How many electrons does this thing have? Since you notice, this thing has a -2 charge, more negative, meaning it has more electrons. It has gained electrons. So it's supposed to have 8 electrons if it was neutral. But since this is -2, this must have gained 2 electrons. So now your electrons will be 8 plus 2, 10. Okay. Now, if you're still confused on why we're adding subtracting, let's just do the oxygen. Oxygen is 8 and 16. So it has 8 protons. 16 minus 8, 8 neutrons. And then since it has 8 protons, it must have 8 electrons because this thing is neutral. It has no charge. When it's negative, what happened, guys? It must have gained something negative. And what is negative? Electrons. So you need to add 2 electrons. So it originally had 8 electrons, but now O minus 2 has 2 extra, so 10 electrons. So I hope that makes sense here, guys. Now, what we're going to be studying next, guys, is, as I said before, we're going to be talking about matter. Okay, so when we're going to be doing the classification of matter. Okay, so again, guys, just to make sure here that you see what kind of questions you're going to see on the exam, guys. If you're going to do the worksheet questions, the multiple choice, the exercises, and practice problems, you will get the idea of what your exam questions will look like. So I might ask you on the exam, okay, Cl -1 has how many protons, how many neutrons, and how many electrons, and this could be your exam questions or something